consider what we call the chain rule, and I'll just show you a demonstration of it, I think, which is the easiest way, and then we'll look at the formalities of it. There's two ways. If I ask you to differentiate this at the moment, we'd have to say, okay, let's expand the brackets. We'll get 4x squared plus 4x plus 4, which then means dy dx is equal to 8x plus 4, okay? What I want you to consider for the chain rule, what if instead I rewrite my function as y equals something squared, same thing, 2x plus 1, all right? So what I'm going to get you to do now is consider if dy dx is equal to the power, differentiate like we normally do, 2 comes out the front, multiply the function and reduced by the power of 1, and so the function is 2x plus 1, all right? But then what we need to do is multiply by the derivative of what's inside the function, which in this case is 2x, and the derivative of 2x is 2. So if I join that together, I get 4 times 2x plus 1, which is equal to 8x plus 4. Okay, so at this point in time, you would think, well, there's not that much difference between those. But let's consider a couple more examples, and I'll show you why it's such a good thing. What if I was to have y equals x squared plus 1 to the power of even 4? How would you like to expand that? You know, use a quartic expansion and expand it all the way out. It's too hard, it's too cumbersome. Okay, what if we said y was equal to 2x squared plus x to the power of a half? How do you expand that? We can't, and it's why our chain rule is so powerful. So let's just rewrite it. Y equals the function that's inside, x squared plus 1. All right, so now again, dy dx is equal to 4 comes out the front. Multiply that power, the function inside still, and take 1 from the power. So that's kind of what we do already. But then we just multiply by the derivative of what's inside, which in this case is 2x. All right, so notice the relationship in there between the red parts, the derivative of x squared plus 1 is 2x, and the 4 out the front with the 3 is the relationship of the derivative of the blue part. So let's join them together. I get 8x times x squared plus 1 cubed. All right. Let's try another one. What if we have y equals minus 6x, say, to the power of negative 2? What does that mean? Exactly the same thing. I'll rewrite it just with the colours there, just to make it obvious. There's my 3x squared minus 6x. To the negative 2. So dy dx is equal to negative 2 at the front, open bracket. Whatever the function inside is, we just leave it there. Doesn't change. Take 1 from the power, I get negative 3 times, what's the derivative of the term inside the bracket? It's 6x minus 6. Yeah? So now, I could take a 6 out the front. Let's just write that in there. I'll go back to blue. So I get negative 2 times 6 outside of x minus 1. And, let's just do it there. 3x squared minus 6x to the power of minus 3. Which means I could write it as negative 12 x minus 1 over 3x squared minus 6x cubed. All right, so we should try to leave it as a positive indice if we can. And that's probably what our back of the book would have for us. All right, last one I want you to have a go at, because these are on that worksheet. Dy dx is equal to, well, actually before I do that, I'm going to rewrite it. Rewrite it as y equals to, that's one function, and there's 2x squared plus x is the other function. So now dy dx is equal to a half comes out the front. Leave the function in there, 2x squared. No, I should do it in red. Don't touch the function inside. Close bracket. A half minus 1 is negative a half times the derivative of whatever's inside, which is 4x plus 1. Yeah. So let's simplify if I can. So what if we put all that on the bottom? 4x plus 1 on top, and I get 2 outside of 2x squared plus x to the power of a half. Okay. Now I can't cancel the 2 and the 4 because it doesn't go into the 1 as well. So I'd have to write that as a half if I was to do that. But that's a pretty good way of leaving it. I could possibly write it as 4x plus 1 over 2 times the square root of 2x squared plus x. All right. So that's our chain rule. Okay. So on that worksheet that we've got, that's what we're looking at now to do a few chain rule questions. All right.